it out.
Do it again.
All right. I got a little talk going on there. Come on, stay with me. What are our knowns? Problem 12. So let's read it. People are having a hard time picking out what they know. When 50 milliliters of water containing 0.5 molar HCl at 22.5 degrees. So what does that tell us? That tells us the volume of HCl, doesn't it?
Yeah.
And what is that? 50 milliliters of HCl. We are also given the volume of NaOH. What is that? 50 milliliters. My TA knows.
Good job, Carla.
And T1, TF, do we know those? What's the temperature of start? You honestly don't even know what? I can't hear it. It is 22. Do you see where we get that? That's the temperature of the solutions before we mix them together. So that is 22.5 degrees Celsius, right? And what does it end with? Exothermic heats up the surrounding, heats up the water, 26 degrees Celsius. Is there anything else we know?
Yeah, we know seawater.
Oh, we do. We know C, H2O, which is 4.18, and that is joules required to heat up 1 gram
Times
1 degree Celsius. That's how many joules it takes to heat up 1 gram of water 1 degree Celsius. Now, what's our unknown? What are we after? Delta H in, is the question, in kilojoules they want it? Okay. Now, do we have an equation for this? Delta H. Now, this is giving off heat to the surrounding, right? Because this is exothermic, so we could call it minus Q, right? Okay? And that would be equal to the minus mass, we're just putting a negative on it because we know the whole thing ends up negative, mass times what for us? Say C. C. Times
delta T.
delta T. All right. Yes. Now, how do we get the mass? I don't see mass anywhere on here.
Oh, so basically you convert the milliliters into grams.
Oh, then we also have to know, as a given, let's just write it off to the side if you don't have space, that the density of H2O is 1 gram per milliliter. Make sense? So, if we add both these up, we're pouring them together, right? That's what we're doing to make this reaction go. Then we got 50 plus 50 equals 100 milliliters. And at 1 gram per milliliter, how many grams are we going to have? All right, so we then know that the mass here is 100 grams of water, right? So we got that one done. Oh, we already have this one. Oh, we still got to do a calculation on this, don't we? That is delta T equals T final minus T initial.
It's 7.
What is that? What is that? That's 26 minus 22.5 equals
3.5.
3.5. We got it. 3.5 degrees Celsius. So do we have everything we need now to solve that thing? You see how I'm doing this? Just chinky, chinky, chinky. What's the what?
The letter before T, or whatever. No.
Delta.
That one.
It's
Is that
delta.
Delta?
Delta. It's just a triangle means the change of T, and we changed from 22.5 to 26, That was our initial, this is what we ended up with because it's exothermic, it's giving heat off to the surroundings.
We get 3.5.
Yes. So we got 100 G, 100 G, right?
Yeah, 100 grams.
Minus 100 G times 4.18 joules per gram degrees Celsius times 3.5 degrees Celsius. Now, before we solve and do the math on this, what do we always do? Yes.
Cross out the variable.
Dimensional analysis. We analyze, are we getting the right unit?
So just cross off the grams and the degrees.
All right.
Yes.
We're multiplying by grams, we're dividing by grams, they're gone. We're multiplying by the degrees Celsius, we're dividing by degrees Celsius. That leaves us with joules. Is that what delta H ought to be in? Is that a good unit for delta H? Banga-zanga. And what do we get? Do the math. Minus.
1,463 joules.
But they don't want joules. They want
kilojoules.
kilojoules. 1.46, let's just round it. 1.5 kilojoules. We got it? Everybody see how to do this? Banga-zanga. All right.
Yeah, what's behind the poster? Like,
Who are you taking notes for?
All right. I'll wait for a second while you're doing that. With fourth period. So, I'm not looking, you tell me, what are our knowns?
We know
I think
that
that's
I don't
T1, Ti equals what?
25 degrees Celsius.
25 degrees Celsius.
TF
TF
equals 26.4 degrees Celsius.
26.4. Well, let's just do delta T right now, being TF.
1.4.
Let me just bypass all that. You all know that equation now, don't you? 26.4 minus 25 equals 1.4 degrees Celsius. That's our change in temperature. Good? All right, what else do we know?
we also know that the degree seawater is 4.18.
All right, C, 4.18
Oh.
joules.
Is it just C? Okay.
Yeah. C, well, no, H2O, it is the C for H2O, it's the heat capacity for H2O. G, degrees Celsius. Now what else? We need to know mass, don't we? What's the mass?
Although some people don't like mass.
It's a little massy, isn't it?
So two hydrogens is one or two, and then oxygen is right?
25 milliliters of water. We know the density is water is 1 gram per. So our mass is equal to 25 G. Right? Did you follow? Who didn't follow? Raise your hand if you didn't get that. So everybody got that. All right. So delta H. And this is a little rock giving off heat, so we're going to be minus again.
What's our unknown?
Oh yeah, what is our unknown? It's got to be delta H, isn't it?
Yeah.
Delta H in what? In kilojoules or joules? Just joules? Okay.
Oh my God.
So we know this is going to be negative. It's cranking heat out to the surrounding. M, C, delta T. And we got all those, right? We got 25 G times
4.8.
4.18 joules per gram degrees Celsius times 1.4 degrees Celsius. Dimensionally analyzing, we're left with joules, which is what we want. What is that? What is that?
What is that?
That is 140, negative 146.3.
146.3.
Banga Zanga!